Hello everyone, and welcome to the Regular Expressions lecture. Regular expressions are text matching patterns, and they're described with some sort of formal syntax. So you'll often hear regular expressions used for finding repetition, for matching text, etc. And as you advance in Python, you'll see that a lot of your parsing problems can actually be solved with regular expressions, and they're also a common interview question. So if you're actually familiar with Perl, you'll notice that the syntax for regular expressions are really similar in Python. The module we're going to be using is the Regular Expressions Operations module, which is just RE in Python. Here I have opened the documentation page for it. You can see it's pretty extensive, and there's a ton of stuff you can do with regular expressions in Python. We're just going to be going over the most useful functions it has. But again, I encourage you to check out the entire Jupyter notebook that's associated with this lecture. But let's go ahead and get started with some live code so we can see how it works. So let's say I want to search for patterns in text, which is one of the most common uses for a regular expression. First thing I'm going to do is import the regular expression module. Next, I'm going to make a list of patterns. And these are just going to be two strings, term1 and term2. Then I'm going to make a large text string, and it's going to say this is a string with term1, but not the other term. So notice it has term1 but not term2. So how do you actually use the regular expression module? So one of the features you can use is search. So we can use the search method, and we can search for a particular pattern. So in this case, I could search for, just to show you an example, hello. And then the next argument you pass is the text you want to search. So I can say, hello world. I need to close off the parentheses. And notice how you get a match object. That's something I want you to keep in mind as we go throughout a larger example. So you're going to get a match object, and it's actually more than just a Boolean. So what I'm going to do now is hop over to the Jupyter notebook and copy some code right here. And then I'll break down the code. You can go ahead and feel free to copy this code as well, just to save you some typing time. But what this code is going to do, it's going to say for pattern in patterns. So for every term in this patterns list, it's going to print searching for the pattern in that text. Then if search pattern text, so if that match object exists, then it's going to print match was found. Else, which means no match was found, it's going to print that. So if we go ahead and run this, you'll notice it was able to say searching for term1 in this string, match was found. Searching for term2, no match was found. Okay, so we've seen that the search method will take a pattern, scan the text, and then return that match object. If no pattern is found, a none is returned. So I can go ahead and check that out. I can say read.search, put in H here, and then give it a W, so there's no match. And we can go ahead and print whatever that is. You'll notice it's none. So a none is returned if there is no match. Now, let's go ahead and take a closer look at this match object. And what I'm going to do now is just say this match equals search of, let's just say patterns, the first term, and then the text string. And now let's check the type of that object, match. And you notice we get this match object. So it's actually a lot more, like I said, than just a Boolean. It also contains information about the match, including the original input string, the regular expression that was used, and the location of the match. So we can actually call methods on this match object. So for instance, I can say match.start, and it will actually tell me the index of the start of the match. So at index 22, the pattern started to match with the text. It can also show me the end, so I can say match.end, and likewise it shows me the index there as well. Alright, so that's just something to keep in mind as far as the match object that the regular expression module returns. There's a lot of methods, and I encourage you to go ahead and explore them if you find yourself needing to. So you can see there's a ton of methods here that you can use. Go ahead and explore those here or within the documentation. All right. Moving along, now we're going to see how we can split with regular expressions. This is going to be one of the most useful features of regular expressions. So it should look really familiar to you given the split methods we've already seen on strings. And let's go ahead and see what it looks like just purely in the regular expressions module. So I'm going to say split underscore term, which is going to be, let's say, at. And now I'm going to put a phrase in. So I'm going to say, what is your email? Is it hello@gmail.com? Question mark. All right. So let's say you wanted to split at this split term, at. So you can use the split method and say split term, give it the phrase, and it will return a list with the split, not with the split term included. So this should look really familiar given what you already know about splits in a string. So if I say hello world and I call the split method that the string has built in, it's really similar. So the split returns a list with the term to split on removed, and the terms in the list are a split up version of that string. So make sure you can understand this example fully. So go ahead and create a couple more examples in case you're unsure of what's actually going on. The reason I chose the @ symbol here is that's sometimes an interview question as far as how would you split domain names from an email address. The answer is pretty much always regular expressions as far as one of the most efficient ways to do that. Now what we're going to do is move on and talk about finding all instances of a pattern. And with that, you can use the find all method. So I can say find all, and what it's going to do is return a list of all the matches. So for instance, the first thing you put is the pattern you want to match. So let's say I want to match the actual word match. And I'm going to put a string that says here is one match, here is another match. So right now there's two matches in that string, so it will return both instances of that. So find all will find all the instances of your match. So what might be interesting is then you can count the length of this and it will tell you how many matches there are in that string. Okay, so the bulk of this lecture is going to be on using the RE module syntax of Python. And what I mean by that is the regular expressions, it's going to support a huge variety of patterns that just simplified finding where a single string occurred. And we're going to do something called using meta characters. So let me go ahead and show you what I mean by that. Let's go ahead and jump back to the Jupyter Notebook because it's a little more clear there with some markdown text. So let's scroll down. Here we go. So finding patterns and this syntax, what does this actually look like? So before we began, as far as going through the different syntax, I created this function here, and it's called MultiRefine, and it takes in patterns and then a phrase. So it takes in a list of these regular expression patterns and prints a list of all matches. So it goes for pattern in patterns, print, searching the phrase using recheck, pattern, then it says find all. Okay, so I'm going to go ahead and copy this function. You can go ahead and copy it as well and paste it here. And what we're going to be doing now is going through different syntax. And this is actually best explained through this IPython notebook. So there's repetition syntax. That's the first syntax we're going to be covering. So what I have here is repetition syntax, and there's going to be 5 main repetition syntaxes we can use. And they look a little something like this. You have a star, a plus, a question mark, curly brackets with 1 number, or curly brackets with 2 numbers. So let me break these down and how they actually work. And what I encourage you to do to get the most out of this lecture is just take your time and read the Jupyter Notebook, take the code like this, copy, and after reading the explanations in Markdown, go to your own live Jupyter Notebook, run it, and then check the results and make sure they make sense to you. So Let's go ahead and start with the repetition syntax. So if you use a star or an asterisk, then what this basically means is take an S followed by 0 or more D's, which means basically take anywhere that starts with an S. So if we look at our test phrase, this particular pattern returned anywhere that started with an S. Then what the plus sign does, it says S followed by 1 or more D's. And I know this general syntax looks strange, but that's the way regular expression in Python work. So here we can see anywhere where there was an S followed by 1 or more D's. So we don't get all these single S's. Next output for repetition, or syntax repetition, is a question mark, and that will be S followed by 0 or 1 D's. So if we look at this, here's basically output of 0 or 1 D's, no more than that. So if you have these 2s or 3s, those don't show up in the question mark syntax. After that, there's curly brackets, which will just be allow you to specify how many repetitions you want. So this says S with followed by 3 D's, and this says S followed by 2 or 3 D's, and you can continue on as you go throughout your code. Okay, so go ahead and read over the general explanations for each of those, which are just basic explanations of what I just said, and go ahead and test out the code yourself here. So I know there's a lot to read here in the regular expressions, but the most important thing is that you just feel comfortable using this syntax: pattern, phrase, because you can always look up these exact test patterns as far as syntax later on in this Jupyter notebook. So we went over the repetition syntax. So there's 5 ways to express repetition. And now what we're going to go over is character sets. So character sets are used when you wish to match any one group of characters at a point in the input. And we use brackets to construct character set inputs. So for example, this input for AB searches for occurrences of either A or B, which is a little weird because you might see brackets and think, oh, that's a list, where's the comma? But in this case, for regular expressions, there's no comma there. So here, you pass a string as a pattern with brackets, and it says either S or D. Look for either of those 2 patterns. So basically, everything where there's an S or D gets returned. And now I can add something like this. I can say S followed by 1 or more of S or D. So notice how I'm adding now repetition syntax to this here. And you can see the results here. So it's S followed by 1 or more S or Ds. So it kind of makes sense that the first SD returns every instance. This is just looking for S or D. And the second bit will just return anything starting with an S in this particular case, since our input test phrase looks like this. All right. So moving along, let's look at exclusion. So we can use this caret to exclude terms by incorporating it into the bracket syntax notation. So, for example, bracket, caret, and then whatever terms you want will match any single character not in the brackets. So let's go ahead and look at some examples. So I have this test phrase that says, this is a string, but it has punctuation. How can we remove it? So I have a caret here, and then a bunch of punctuation, an exclamation point, a period, a question mark. I'm going to zoom in so you can see that. So here, what I'm doing is passing this caret, and then it's going to have exclamation, period, question mark, space, and then a plus sign. So remember, we add that plus to check that the match appears at least once, which basically translates into finding all the words in that string, right? Because I'm saying return everything where this caret allows us to exclude those terms, which is just all the punctuation terms. So this is the kind of regular expression you can use to remove punctuation from a string. And note we get a list here that says this is a string, but it has punctuation. How can we remove it? Now there's no punctuation there. All right, we'll move along now to character ranges. So as character sets grow larger, typing every character that should or should not match can become really tedious. So what you can do is a dash expression. And I'll show you what I mean. So here are some test patterns we're going to check out. So let me zoom out so you can see them all. Whoops. Here we have sequences of lowercase letters, so we say A through Z. Here we have sequences of uppercase letters, capital A through capital Z. Here we can have sequences of lower or uppercase letters, so A through Z, capital A through Z. And then we can have, again, one uppercase letter followed by one lowercase letter. All right, so go ahead and then check this code out. You can go ahead and copy this and then paste it into your Jupyter notebook and check the results to see if they make sense to you. All right, so for instance, looking at this, this will return anywhere where a capital letter is followed by a lowercase letter. And these are the two results where that happens, this and let's. All right, so that was character ranges, which is basically just that dash notation. And then escape codes. So we've probably already seen a few of these, but something to keep in mind is you can use special escape codes to find specific patterns in your data, such as digits, non-digits, white space, and more. So for example, I've listed all these codes here and their meaning. So for instance, if you say find all, and you put in this code, /D, it'll think of it as a digit. /capital D is non-digit. Lowercase s is white space, capital S is non-white space. And then lowercase w is alphanumeric, capital W is non-alphanumeric. So something to keep in mind in strings, there already are escape codes built into strings. So for instance, if I say print hello \n new line, remember this \n is already an escape code telling Python, hey, this isn't an n, I want you to print this on a new line. So this is where sometimes regular expressions get hard to read. What regular expressions do, so that Python doesn't get confused that there's an escape character already in there, is it adds this R beforehand, and then some single quotes. So if we look at this example, copy it and take it over to the Jupyter notebook, we can look for each of the test patterns. So this first one, /D plus, sequence of digits. So this will return any sequence of digits. Next one is going to return any sequence of non-digits. This is capital D plus. After that, we can get sequence of white space, non-white space. So here's all the white space, here's all the non-white space, and then alphanumeric characters and non-alphanumeric characters. So alphanumeric and then the non-alphanumeric. All right. Hopping back to Jupyter Notebook. So you should have at least a solid understanding after completely reading this Jupyter Notebook. So I don't expect you to learn everything just from this quick overview video. But you should at least have a solid understanding of the general form. So you have a pattern and then the text you want to search. So if we look back to the Jupyter Notebook, it always goes like this. You have either the term, the split term, and then the phrase, or the pattern and the phrase or text. So it always looks like that. Pattern that you're looking for, and then the text. And then where regular expressions really shine are all these basically special pattern codes that will look for like a sequence of digits, in this case, or this will look for a sequence of lowercase letters, etc. We can look at exclusions, character sets, and repetition. So I know that's a ton of stuff, and most people, unless you're using these regular expressions quite a lot in your work, don't memorize this. They will either look at a table or look at the documentation. So, like I mentioned before, go ahead and take a look at the full documentation in case you ever need to look something up. And there's also a nice summary of tables at this source that I've linked to here, Python regular expressions, so you can check that out yourself. Go ahead and make sure you read through this Jupyter Notebook to fully understand regular expressions. But I hope this video helped you out as far as understanding the general syntax.